Hello. Next talk is a pre-recorded one. It's embedding BPMN-driven business process into Plone, presented by Asko Suka.
I'm so sorry that I cannot be there with you today. Life happens, literally. But I still like to show you something that I've been thinking about lately. So my name is Asko Suka. My day job is at University of Jyväskylä, Finland. And that university has been using Plone from version 1.5 at least, if not even before that. For the last few years, I've been able to work less with Plone, but more with business process automation and digitalization in general. Of course, still including a lot of Python, integration microservices, and, well, also some Plone. This year I've been out of the office, and that has given me a chance to think about what I've been learning and how could I bring those learnings back to Plone, hopefully allowing me to work more with Plone in the future. Now, let's get started with a comprehensive demo to show you what this BPMN thing is all about. This is Camunda Modeler. It's the desktop application we use to model our BPMN processes. It is free, open source, extensible, and surprisingly nice to use. And of course, it knows the BPMN extensions necessary to make those processes runnable on Camunda Platform. Technically, this is an electronic application, which means that it is based on web technologies, and because of that, with some effort, the same libraries powering it can be also used for embedding its modeling experience directly into custom web applications. Now, because I have not yet integrated this one into Plone, let's use this tool to model our minimal feedback process and then embed that process onto a Plone site. What we see here now is maybe the simplest process possible. It has a start event, a flow to the end event, and it does absolutely nothing. Next, let's customize this to be our minimal feedback form process. For such form-driven process, it makes sense to start the process when a visitor submits the feedback form. So let's label the start event as feedback form submitted. Feedback form submitted. Then we could add an activity, a task, to send the feedback forward by email. So we drag a task here. It could be send task, and we label it send feedback as email. And finally, we can label the end event as feedback received. And this would end our minimal feedback form process. Now, documentation-wise, this diagram is already complete, but technically it still does nothing. So what makes BPMN 2.0 distinct from the other modeling standards is that it can also define how the processes get executed, which means that this diagram can also be the actual code that executes, runs, and controls the process. This also guarantees that as a documentation, this diagram is always up to date. To make this process executable, of course, we need to enrich this diagram with some implementation details specific to our process engine with the open source version of Camunda Platform 7. To do that, we need to build the form to start the process and configure this email send task. Let's start with the form. Technically, we are allowed to use any form technology we wish and then take the data from the form and call Camunda REST APIs to start the process with the data from the form. But today we are using something called Camunda Forms because those we can create directly from this modeler. So we go to File, create new file, and select Form for Camunda Platform 7. Our form will have simply the title. Let's call it feedback form. And still we have one field. It would be the feedback field. And we will save the value from this field to variable called text. And finally, we need a button to send this form. Let's call it just submit. Now we need to give this form an ID. We can call it example contact form maybe use the same name for saving the form. And finally, now that we have this form, well, let's add some helpful descriptions here. So please type your feedback here. So now we have saved this form with ID example contact form. We use this ID to bind this form for the start event of our process. So we choose the start event and go to the forms, choose Camunda forms, and now paste our form ID here. Next, we need to configure the send task for the email. And again, there are many ways to do this. Right now we are using something called connectors on Camunda Platform 7. And there's built-in connector called mail send provided by Camunda. It's running inside the engine. And that requires 3 parameters. Minimal, which would be, first one would be subject. So subject of the email. Let's call it new feedback. And then we have text for the email. We can use the text variable from the form. And finally, we need to define the recipient for the email. So maybe webmaster of our website. For now, webmaster at example.com. And now, finally, this minimal process should be all implemented and ready to deploy for the Camunda platform and for the engine, and then embed on the Plone side. So let's deploy this. Of course, in production setup we would use some kind of CI/CD pipeline to deploy this. But now, because we are just developing and playing around, we can deploy this directly from this modular application to our locally running Camunda instance. Just make sure that we include both the process engine, process model, and then all the other resources the process requires. In this time, we need this form we just created, and we press deploy, and we get the feedback that our process now has been deployed on Camunda engine, and we are ready to embed this on the Plone. Up to this point, to model the process and its form, I've been able to simply use the available open source software provided free by Camunda. But now, finally, I must start relying on my own code. Here we have Plone 6 Classic, and the V5 here on the background, we are also running the customized version of Camunda Platform 7. And those customizations, well, they are available with my Plone add-on, and they allow Camunda to verify, authenticate, and authorize the signed REST API request from my Plone add-on to the Camunda REST APIs without any additional configuration. So it should be easy to use. My add-on is called collective BPMN-proxy, and it comes with a content type with the same name, so that it's BPMN-proxy, and it can be used to embed processes from the engine onto a Plone site, like this. So we have here the basic Plone page information for the Plone catalog, so see search results and things like that. We type feedback from here, and some summary: send us feedback with this form. And here we have a list of all the processes available on our engine configured for the Plone. We choose our contact form process and save the proxy. Now we have embedded this process on the Plone, and we already see the feedback form, the start form we just did a few minutes ago. Now we should be able to publish this process and use this form as an anonymous user. So we go to the Plone site with English in the browser. We choose the feedback form and type some feedback. Hello world, and submit the form. And like that, we see we are getting an email from this form which has the text we entered to the form. So this was how we did embed our minimal feedback form on the Plone site. Next, let's iterate our process a little. So as we saw when we sent the form, we just got this basic submit successful feedback, and it would be nice to give some kind of thank you form for the submitter, for the visitor. So we go back to Camunda modular, And we branch this process so that we can show the thanks. We can both implement the thanks page and then show the thanks page for the visitor. So here we add a gateway. We make it parallel gateway so that we can concurrently show the thanks page for the visitor and send the email at the same time. And here we add a new task here. It would be view thanks page. This is for the visitor. We could call it it's user task because visitor does it. And assign it for the visitor, we need to store the user who starts the process as an author into author variable. So author like this. And now we can assign this view thanks page task for the author like this. Because in BPMN there can be many tasks, even concurrently, for many different users. So somehow we need to assign the task for different users. Here we store the user who starts the process in the variable, and we can then use that variable for assign this task automatically for the starting user. And my collective BPMN proxy takes care that anonymous users have kind of transient random usernames in the engine for the authorization things work properly. Well, of course, we don't want to have any buttons on the thanks page, so we simply there is no way to continue it for the user of the thanks page, but we add so-called boundary event here, so that after a little time, like some seconds, let's make it like 50 seconds or something. So PT5S. After 15 seconds, the process will end. So it feedback sent successfully sent. Yes, or just feedback submitted maybe like this. So what it does is that after a certain period of time, this process will continue from this thanks page task automatically to the end. To really understand what happens in this process, we can use one of the best Camunda modeler extensions available. That's called Token Simulation plugin, and it's installed here. So with this plugin, we can show how this process actually works. So we start the process. We see that this process is split into two different tokens in this parallel gateway. The first one goes to send feedback as an email task, sends the email and end. Then the other one is here waiting for the visitor to see the thanks page, but then after some time it will also continue and the process will end. So this token simulation really helps us to visualize how this process works. So again, the process has now like two states, two tokens concurrently. And once all the tokens have completed and disappeared, now the process have really been finished. What we are now missing is implementation for this page. So again, we can use this Camunda Forms for Platform 7. And let's just add some thank you text. Thank you for your feedback. And now we need no buttons because we are just showing this nice feedback test for the user. So example contact form, thank you. And we also want to use this as an ID for the form. So let's save the file and then set the same name also form ID. So it would be example contact. Oh, example contact form. Thank you. We save this once more. And now we bind this form for the view thanks page user task here. So let's use Camunda forms and reference will be this name. Thank you form. And now we should be able to deploy this process again. We need to add this new form here. So thank you form. And now we deploy the process with same process with this process file and then 2 forms. And now the Plone will automatically use the latest version of the process. So we simply go back to form, reload the feedback form page, and send new feedback. And now our visitor sees the thank you page, and we, at the same time, we also get the email. So that's how you can easily iterate with these processes, simply by using Camunda Modeler and redeploying the process with all its resources. And once we have enough time to iterate on this process, we might end up with something like this. So this is no longer our simplest possible feedback process, and now we really need the token simulation plugin to see and explain what's really happening here. So the process still starts like the first one, the previous one, where visitor submits the feedback form, and then is shown the thanks page, and then after some time the thanks page will expire, and this visitor track is completed. But now, instead of just sending the feedback as email right away, we want to look into the feedback and check if that's really some word of sending and to whom we should send it. And for that we could use small machine learning tasks. So these are so-called external service tasks, where this task is then taken by a microservice. So the workflow engine just holds like a task queue for the microservice to poll for a new task and then execute those tasks and return the results. And now, if we started with empty models for those machine learning tasks, these of course end up with finding nothing. So we don't know if it's spam or what's the mood or what's the topic of the task, and then it goes to manual sorting. And manual sorting task is just again a user task where we have form for it somewhere here. Let's see. It's this form, so where the user can check what's the mood of this message and what's the topic of this message and is it a spam or not. And once the user has submitted that form, now we can use that data to train those machine learning models. So now we have users check that this is spam or not, and what was the mood and what was the topic of the feedback. Now we can continue with the process. So now we have topic for the feedback, and then we choose from decision tables. If we have this topic, then who would be the recipient for this feedback? And here we have example of what this kind of decision table would look like. So if the topic is communications, then we will send the feedback for communications email. And well, if we had special user group for them, we could assign for them. Now we are just assigning every feedback for site administrators. If we were about to use, yes, we will use those group later. And now we have the email where to send the feedback, and we will send the feedback like this. And now this process is finally completed. And now when the next time comes similar feedback, or actually after multiple similar feedbacks, because only then we have trained the model enough. Now the model would already know that, okay, this is not spam, because we have trained it to detect that as not spam, and it knows to redirect the feedback with the known topic, choose the recipient and send the email without us manually sorting the message feedback. Like this. But now, because, well, we are training the model by ourselves, and of course it's not perfect in the beginning, and we still might have exceptions later. We need to have way for the recipients to make a claim that, okay, this feedback was actually not for me. And that's why we have another process, another user task here waiting, that if the recipient got the right form feedback, they can come back to the site and click, okay, this needs to be sorted manually again. And then it goes back for manual sorting, and we can continue training our machine learning models. And maybe next time the feedback goes directly for the right address. like this. So let's now deploy this new model with all the resources. So this model and a few user forms, and then this DMN decision table. Let's deploy all of this to our Plone and see does it work as expected. So we click the deploy button, and yes, we have all the resources here, and we deploy it. Now it will override our previous feedback process. And let's see. Yeah, I did change the title for this feedback page. And now let's write our first feedback that we can then use to train our models. So, hi, really nice logo you have there. I really like it like this. So this is nice feedback meant for the communications to read. So what happens now? Let's go to the Camunda to see what happens. So now we should have a new process here, new version. There should be one instance running. Yes. And we see, well, now we did show the thanks page, and here we have, yes, we have had first run for the predictions, and because we had no data from previous runs, now we have this manual task here for the user to do the manual sorting. And that's available now at our task through our task list portlet. So we got the dashboard and we have this task here. And now we can detect, okay, so this was not meant to be spam, and this is quite positive, and this is meant for communications. Like this. And now we can follow from Camunda what happens next. So now currently it's training the classifiers, and then at the end, quite soon, we should get the email. Yes, it came. So our communication got positive feedback from the feedback form. Like this. And now let's send similar feedback again. So we are really nice logo there. Liking it. And let's go back to see what happens now. So the new process running here. Let's see how it predicts it to be. And it's already done. And now, as we can see from this route, now it was trained that this is for communications and it's spam. So here we see it already. We got the email, and now we have option to change the feedback if we want to. So there is a task for the communications to change it if they want to, but let's leave it like this, and this task will expire automatically. Now let's add some spam. What would be good? Well, some marketing spam. You have one call us now. So this is supposed to be spam. Let's see what happens. It will probably go all the way to the communications directly, because that's the only thing we have trained so far. As seen. So it really wrongly detected being positive feedback for communications, because that's the only thing we have had so far. So let's go, no, this is definitely spam, and nothing else matters here, because yes, it's spam. And why we are seeing this form 2 times is because the first form is for the communications, and the second form is then for the maintainer of this process, owner of the process. So they can still confirm that yes, this is really spam. Let's now train the machine learning to detect that as spam. And now for the next message, we might have better luck. Let's see. So you have one price of just let's see what happens. Let's see where this goes. Yeah, of course, this kind of training would need hundreds of messages to really start working properly. But after that, it will be like self-healing process. So whenever there is like mispredicted mail, it's still possible to fix it later. See what? Oh yeah, there was already enough hints to detect it as spam. Perfect. So now we have for short time, we have task here for the maintainer to fix if we have false positive spam. Let's see, it should be on the task list. So dashboard, yes, this one, and yeah, yes, but it is spam. So we don't need to do anything here. And now let's send few messages. Let's train it to have another topic here. So what would be something for IT? Your site was down yesterday. I was not able to load it. And let's see, this should now not be spam. This will probably again go to the communications because that's the only topic we have trained so far. Reloading. Almost done. Yeah. Positive feedback for communications. Maybe this is neutral feedback for IT, I think. So let's go to fix it. So yeah, this is neutral and it's not spam, and let's send it to IT. And let's confirm it like that. Like this. And now there will be again training happening. And now let's start to send similar message feedback. So, hi. So yeah, natural feedback for IT. Try to load your site yesterday, but it was down. And again, so what is that machine learning there? So it's mostly counting the occurrence of words in the message. But as we see, it works surprisingly well. So already this second email was predicted correctly. Okay, so BPMN is about processes, workflows, and orchestration, including both humans and machines. And we have used to think that workflows are one of the Plone's best selling points, especially for internet and enterprise use cases. And now I'm about to tell you that Plone workflows are often not enough. Plone workflows are designed to manage state of only a single CMS target at a time. Yet, real-life business workflows often touch multiple targets, require some concurrency, so multiple events happen at the same time, and those can even span across multiple systems. When this is the case, using a single CMS item state to represent the related business process activities may become artificial at best and misleading at worst. Also, it is not uncommon that some business processes can run for a very long time. And being able to iterate with those kind of processes already in production really requires some kind of real versioning support also for the workflows in the used workflow engine. Well, for more in-depth reasoning, for more capable workflow engine when implementing these kind of real-life processes, business processes, I really recommend watching a previous Plone conference talk from 2016, Making Workflows Work for You by Stefan Richter. That all said, I have implemented a lot of business processes with Plone workflows in my career, and while we have had a lot of success with Plone and workflows, I would still like to say that in my experience, a single Plone site just does not scale for a lot of workflows. Technically, of course, there's no real limit for the amount of workflows in Plone, but when you try to implement many different processes for a single Plone instance, like an intranet, you end up having so much different workflows, user roles, form content pages, and content rules, and those instances configurations, that it's really no longer possible to see forest from the trees. So yes, you have a Plone site with a lot of running workflows, but just looking at that Plone site, it is impossible to figure out what processes that Plone site is really running. So it all just becomes spaghetti. And that brings us back to BPMN. So this was an example of a little more complicated process implemented with Camunda and embedded on Plone. And I think this level of complexity is already something that I would prefer not to implement without helpful workflow tool like this. So I think this really already benefits from having BPMN backing this process. BPMN 2.0 is a business process modeling standard which scales for complex processes without being too complex by itself. It has just enough features to cover most of the known workflow patterns, and it works both as a visual documentation for humans and machine-readable code for workflow engines. We have already seen this BPMN example in the previous demo, but let's revisit the main features we had here. So our demo process includes human tasks with form-based user interfaces made available through our Plone site. And it also includes machine tasks which were completed by microservice workers running independently from Plone. And it includes business rule tasks with easily maintainable DMN tables, decision tables, to avoid unnecessary branching on the process flow. It joins branches back together. At last, there were events, the most interesting ones being interrupting timer boundary events to time out incomplete tasks for letting the process continue without any user action for those particular tasks. Let's also say a few words about DMN. So DMN is the standard for decision tables used in business rule tasks in those BPMN processes. It's like the sibling standard for BPMN, and these two standards are really designed to be used together. DMN is simply a table with columns of inputs and outputs. And the standard defines the possible ways how to match the inputs with the correct rows to get the outputs. Our example, we use so-called first hit policy, which means that only the output from the first matching row is returned. Finally, we had forms. They are not part of these standards, but as we know, forms are nowadays still the most common way we interact with the various information systems, at least until something better gets invented. Now, collective BPMproxy is my index. It's not meant to be, nor never will be, a replacement for Plone workflows. Its main feature is to embed BPM processes from Camunda Platform 7 into Plone with help of a custom content type BPMproxy. This would allow reusing the same BPM process in different places of the site with context-aware configuration. The second best feature, in my opinion, is content rule action, which allows to broadcast so-called BPM signals at the engine. This would allow any Plone content to interact with the BPM processes running on Camunda instance. For example, these signals may be used to start augmenting processes for the Plone workflows on existing Plone content items, which of course will then require this add-on to make the related forms available also for those content types with the custom traverser. The add-on supports Plone string interpolation for customizing the processes with context-aware variables and to provide default values for form fields. Also, vocabularies are supported on forms, but only within the limits of Camunda Forms library. Also, there is a task list portlet to display all the available tasks for the current user. And because Camunda Platform is not designed really to store files, I've been experimenting how to make it easy to store required attachment onto Plone instead. Finally, the Camunda Platform 7 customization for the add-on makes it possible to use Plone authorization, active user and its groups at Camunda. At first, Plone can be used to limit who can start the process in the first place, and then Camunda takes care that only the authorized users can access the active user task on each process. So with these features, the add-on should be able to support at least these few use cases. At first, the add-on could be used to build complex form wizards by chaining many BPM user tasks and branching the process by the values submitted by these forms. It's also possible to build standalone form-driven processes where Plone users and groups just work as expected. And it's possible to augment the existing Plone content workflows with BPM features, which I will show you soon. Because one Camunda process could be made available many times in Plone and configured with context-aware string interpolation, you can put Plone hierarchies in good use with this add-on. And the possibility to augment existing Plone workflows BPMN and then use external service tasks in BPMN effectively makes it possible to extend Plone asynchronously with independent microservices with this add-on. And now it's time for the demo about augmenting existing Plone workflows with BPMN, what I promised you. So, a couple of years ago, we had a external review for our Plone sites, and the main issue, I think, was that we had way too much content. So let's try to make that publishing content a little more expensive and more difficult. And we do that with this BPMN process that augments workflow for published content. And again, we can use, so we are again on Camunda Modeler, and we will use token simulation to check what this process really does. BPM signal on Camunda engine that will start this process with the UUID of the Plone page. It will configure the process with the UUID, and then it will go to wait for some time. And when the time has completed, then the process will continue and prompt the user to update the page. And when the user has updated the page, user will acknowledge, okay, I have updated the page. This is now current again. It will start over and start waiting again. And while we are doing this, we can also augment the process with other stuff. So whenever a page is published, we can, for example, ask, would you like to share this page to some social networks? And then do the publishing with external task worker. Now, if we go to update the page outside of this cycle, then Plone will send us page modified event again as BPM signal, and it will fire this boundary event here, and again this counter will start all over. Now, of course, one option for instead of updating the page, we can delete the page, and again we can configure Plone to send and broadcast BPM signal about deleting a page here. And what will then happen, we will shut down this whole process because the page no longer exists. Of course, other things that may happen is that the page no longer gets to be published. So someone will unpublish the page, and the Plone default workflow allows to reject the page or retract the page. And well, to keep this augmented process as simple as possible, we capture these events separately, and do the same thing, we cancel the process. And finally, what's possible here? Of course, something may happen with the Plone and the Camunda Platform, so that the page disappears from the Plone without firing the event or without the BPM signal content rule action never reaching our Camunda platform. That's why we could have a scheduled cleanup check within the process. So like every day, Camunda will trigger this sub process, and it will trigger external code that will check, does this page still exist? If it still exists, then nothing happens. The process will stay away. But if it happens so that the page is no longer there, then using BPM technologies, we fire internal signal within the Camunda platform engine, and it will shut down this process. So all these within Camunda platform and maybe with external microservices without writing a line of code inside Plone. Obviously, now you want to see this live. So this process consists of this main process definition. Then we have a few forms here to choose the share options and update the page. And when we deploy, we need to deploy all these 3 files. So let's do just that. Yes. And now we can go to our Plone site. And I have already written the content rules we need for this. I can show you them quickly. So let's go to Plone site preferences and then find the content rules from here. So I have configured a lot of content rules. So it sends signal when we publish a page, and then signals for doing any workflow actions for published page or deleting this page. And what these do? Well, they trigger the publishing page triggers signal with static name, and then it defines sends the page UUID as a payload. And these other signals include the UUID of the page in its name, in the signal name, and that's how we can restrict the signal be captured only within the processes that consider this page. So we create a folder. Augmented content. And then we apply all these content rules for this folder. So yes, it's a lot of content rules. I'm sorry for that, but it keeps this atomic and clear. And now we add a page here. And yes, we save it and publish it. And now something should have happened. At first, we can go to Camunda, see that yes, there is one instance running of our publication lifecycle workflow, and here we see it's waiting for the time to pass, or here waiting for us to reject the page or retract it or delete it. And again, I think I have put very quite short timers there. So let's see if we are able to see the task on the dashboard, if we are fast enough. Yes, there's task list work for choosing the share options here. So we can check something here. And now it just goes back to the page, and here we can see here we can see that it's now waiting for our integration to take the work from queue and then do the sharing. But this time I haven't implemented the worker, so nothing will happen. But process will wait until this timeout will happen. And now the page is considered outdated, and there should be a task for me to update the page. So I go to the dashboard, and I see this new task on my task list. And yeah, now it added the form has uses string interpolation to give us a link for the page, so I can go and edit it. And now because I'm outside of that sub-process, outside of this sub-process maintenance loop, I can update the page as many times as I want. And now when I finally go to the task list and acknowledge it, like this, now it starts all again. So the process went to this maintenance loop again. And well, there's some magic now in BPMN-proxy that if I'm able to, if there is a new task immediately available for me at the engine, it will give me that task immediately. So that's why I see this share page form already here after acknowledging the page. And now I waited too long, so the task was no longer there, but it was already waiting to update again. So now if we here like this, but this time, no, I think it's better that we delete this page. So or maybe we just retracted it. Okay, this is let's make it private now. Now it's private, and if we go to Camunda, the process is no more, and we can only see the process in the history, where we can see what were the things we did with this page. And this history is only available as long as we configure it to be. So this was the way how we used both the features of BPMN and features of Plone, content rules specifically, to augment the standard Plone application workflow with BPMN-defined process. Finally, I have to admit some drawbacks and missing features with these tools. At first, all of them, BPMN, DMN, and Camunda forms, completely ignore all internationalization and localization requirements. Well, that's a real big issue, and I'm sorry there is no simple workarounds for that. Well, Camunda Platform 7 is a Java service, and it would require at least matching resources with Plone, running Plone site to run it. So it will double the resource use for your service. But because Camunda supports multi-tenancy, I think I can make collective BPMN-proxy to work so that you can use one Camunda instance for many Plone sites. Also, it multiplies the deployment complexity, because now you have deployed Plone and Camunda, and if you're using microservices, you need to deploy even more. And it would be cool to understand at least something about all these new technologies, Java, and my custom Camunda Platform 7 is based on Java Micronaut, a framework, and then also understand the BPMN DPMN standards and these Camunda forms. And that Camunda form library is still young, and it's just a toy when compared to things many of us have used to do with all the usual form frameworks for Plone. And at last, Camunda itself has a current issue with naming its products. Collective BPMN-proxy is based on Camunda Platform 7, but earlier this year Camunda rebranded their new solution as Camunda Platform 8. Even Camunda Platform 7 is expected to be supported and even developed further in the foreseeable future. Technically, they are very, very different products, and I think they won't ever have full feature parity. And also, the licensing is different. Camunda Platform 7 is licensed under Apache license, so it's fully open source. But Camunda Platform 8 has custom license that even the source is available, it restricts many usual use cases if they compete with their commercial offerings. So, I think that's all I had time to say today about embedding BPMN-driven processes into Plone. All the code is available at GitHub, but don't expect me to do stable release anytime soon. So, thank you a lot for listening, and enjoy the rest of the conference. Thank you.